Hello, I'm Simon from Newcastle, Australia, and I'm one of the leaders of Working Group 1, Selection of Code Segments for Exclusion from Code Similarity Detection, which is a bit of a mouthful, so let's try and explain it to you. You can see there a list of all the people in the working group and where they're from, but why don't we look at pictures instead? This is me in the top left. Then we have Oscar Kanalim, who is a co-leader with me and who is presenting this session with me. We have Judy Sheard, who is the third leader, also from Australia. We have Ilir Dema from Canada, Ame Karkare from India, Juho Lainanen from Finland, Michael Liut from Canada, and Renee McCauley from the USA. So what is code similarity detection? Some people who teach students about programming like to check the students' programs to see if any of them are more similar than they should be. If we find unexpected levels of similarity, then it's possible that the students have worked together on the same task instead of individually. That's called collusion. Or it's possible that they've copied some of their code from the same external source, which is called plagiarism. Now, establishing similar code, finding similar code, doesn't say the students have engaged in misconduct, but for the interested educator, it helps them decide which program pairs to investigate to decide whether there has been misconduct. And quite often they use tools to help them detect code similarity, tools such as JPLAG, MOS, SIM, and Sherlock. Just an example to show you what we're talking about. This is a very short assignment that I set earlier this year. We've got two dates, month 1, day 1, and month 2, day 2. And we know that month 1, day 1 is before month 2, day 2. And we know that they're in January and or February. And we want to know how many days between these dates. Now, the way I'd be inclined to do that, and the way about 130 of 150 students did it, is to take the difference of day 2 and day 1, and then if the 2 months are not the same, add 31 to that difference. And then you've got the number of days between the first day and the second day. Here's another approach taken by 2 of the 150 students. They made a list of the numbers from D1 to D2, and they made a list of the numbers from D1 to 31, and they made a list of the numbers from 1 to D2. And then they said if the 2 months are the same, the difference is the length of the first list. If the 2 months are different, the difference is the sum of the lengths of the second and third lists. It's a fascinating solution. When we're using software to detect similarity, we basically want to tell it, approach 1. Yeah, I know 130 students did that, but we don't want to be shown that because it's what we expected anyway. But approach 2 with only 2 students, yes, we want that drawn to our attention so that we can consider whether those students have engaged in misconduct. And the point of this working group is to determine what sort of code we can tell the software to ignore because we're not interested in it. Okay, we've got 7 institutions between us. We cover 27 distinct courses, most of them many offerings of the same course, covering first, second, third, and fourth years of study. Altogether, we've got about 500,000 student submissions, which is way more than we can reasonably process, so we are having to be somewhat selective. We're covering C, C++, and C#, Java, Python, Haskell, Scheme, Prolog, and SQL. We've got various kinds of assessment, such as exercises conducted in the lab, assignments that students take home. And we think that it's possible that different types of assessment offer different opportunities for misconduct. So we're going to look at those individually. Oscar.
Okay, so there are several possible items for exclusion. The first one is boilerplate code, like public static void main string args. Code that is necessary for compilation purpose, like required libraries. Code that is the only way to achieve something. Code that is the only way that has been taught in the course. Code that is readily copied from various legitimate sources. Code that is provided as part of the assignment specification. Code that is suggested by the lecturers, tutors, or even teaching assistants. Code that arises from existing student habits. Code that is easily memorized. And code that is generated by IDE wizards. We also plan to do a survey, informally asking people if they provide code when setting assigned work, and if so, what sort of code and why. We will summarize the responses, and if you are interested, please email Simon. Our report will include an explanation of the context of our work, a clear picture of the extent of our data, the method that we have used to reach our conclusions, explanations of the types of code that we believe can safely be excluded from similarity detection, some guidance on applying our findings when using code similarity detection software like GPLEC and MOS, and some guidance on using code similarity detection software to begin the process of detecting student misconduct.
So that's our project in a nutshell. We hope that once we finish the report, the reviewers will like it, it will be published, and you'll have the opportunity to read it in full. Thank you.